gosh.
Hi, my name is Dr. Stuart Ravnick. I'm the Associate Dean of the Graduate School for Biomedical Sciences at the University of Texas Southwestern in Dallas. We're here today in front of our magnetic resonance imaging machine to talk about a study by Drs. Liu, Hart, and Cullum, scientists here at UT Southwestern and at the UTD Center for Brain Health. They have made a very interesting observation looking at both brain function and brain imaging of retired football players. So we're going to be exploring different aspects of how concussions can be measured using neuropsychological testing and brain imaging. Well, hello, Dr. Hart. Thank you for your time today.
You're welcome, sir.
Before we get into some of the questions regarding the study about the professional football players, we're all talking about concussion, but concussion sounds like a huge thing. What is a concussion?
That's a really great question because there's a lot of definitions out. From my perspective, a concussion is when someone has trauma to their head, and as a result of that, they have some change in their neurological, neuropsychological, or psychiatric functions. And that would be either mood, dizziness, confusion, inability to process information, unsteady balance. So any sort of set of symptoms that one would get after head trauma, to me, qualifies as saying that someone has had a concussion. And they don't have to be for an extended period of time. So what we start doing is then defining what are those symptoms and how long as we try to classify concussions.
In regards to the study, we were looking at different professional football players and what happened to them in terms of brain function and brain structure. But how did we know the questions to ask going into it? What were the lead-up points for why you wanted to do this study?
Oh, I had some folks I had seen in clinic, and it was very evident from that there was not some straightforward answer to this. There's not a magic bullet sort of thing that goes, oh, if you have this, then obviously these are the guys in trouble. So we knew we needed to put together a really strong multidisciplinary approach, including psychologists, neuropsychologists, neurologists, and imaging experts to look at what are the factors that are there to have some people with basically the same history as another group of individuals, yet some are more susceptible to developing these really late in life changes in terms of mood and cognition, while others seem to be doing perfectly fine.
So in terms of the tests that you wanted to look at in the study, what was the specific hypothesis that you were trying to look at?
We really wanted to see what sort of mood and or cognitive problems these individuals were having, and did they look like other typical aging-related problems? Were there other neurological issues that were there that were sort of specific to concussion? And then try to match those up with the imaging findings to see, can I find some sort of marker in the brain that says, oh, that region we know is associated with this function, and there seems to be some irregularity in that brain structure.
And my final question, in regards to looking at the white matter, the gray matter, the different structures of the brain, this study used magnetic resonance imaging. Is that important, or could you have just used X-rays?
X-rays, and what we normally, when we're X-raying the brain, you wind up with CT scans, and computed topography is just putting layers of X-rays together. While X-rays give you some information, MR imaging gets you a picture that looks very much more like the structure of the brain. It gives me lots of voxels, meaning lots of little boxes that I compartmentalize every little piece of brain that I'm imaging so that I can compare them statistically to other areas. The other part that's really practical about it is there's no radiation involved. So I can keep doing MRI scans at a relatively frequent rate longitudinally without any risk to the patient. So getting better information and less risk is, I think, why we wind up using MR.
Well, thank you for your time today.
You're welcome.
Appreciate it.
Anytime.
So we're here with Dr. Hanzang Liu, one of the study members from our program at UT Southwestern, the Advanced Imaging Research Center, and a colleague of Dr. Hart, Dr. Liu. Welcome, Dr. Liu. Thank you very much.
Thank you for having me.
In terms of how magnetic imaging machine works. How important is it to know the strength of the magnetic field?
It is very important. Let me give you an example. The MRI scanner behind us is called 3 Tesla MRI scanner. Its field strength is about 60,000 times greater than the Earth's magnetic field.
Wow. And how can you fine-tune that for looking at how the water molecules align, like you mentioned?
You use different so-called power sequences. MRI is a very powerful imaging instrument. First, because it's not non-invasive, it does not use radiation. The second important reason is that it's very versatile. It can look at different aspects of the body's physical property and physiological property. For instance, within the same session, let's say 30 minutes, you can look at the blood flow of the brain as well as the white matter structural integrity of the brain without even moving the patient.
That's amazing. So the students that are watching this video might have done some simple experiments in their classroom looking at magnets and magnetic fields and how to think about how magnetic fields work. When you are looking at an MR machine, how does that scanner generate a magnetic field? And is it just one magnetic field or multiple magnetic fields?
There are at least 2 types of magnetic fields. One is a static field, in which it's just pointing to one direction. It does not rotate. And this is the 3 Tesla that we are talking about, which is 60,000 times greater than the Earth's field. The other type of magnetic field is a rotating magnetic field. It's rotating at, in this case, 128 megahertz. So it's rotating very rapidly. And interestingly, this frequency is also what the water magnets are rotating along. And this is why it's called resonance, because they have the same frequency. And using this rotating magnetic field, then the water magnetic field can be received by our receivers.
Okay, so for students that are interested in physics and magnetism and engineering, they have to actually know how to combine a static field and this rotating field that makes it magnetic resonance imaging. Is that correct?
That's correct.
Getting back to the brain imaging in this study, what kinds of differences did you see when you looked at the football players? You mentioned the multiple deficits in the white matter. How would you correlate that to brain function? Can you say that a patient who has this type of deficit will have this type of neural function disorder?
Right. We found that the blood flow pattern abnormalities is strongly correlated with the known function of the brain. For instance, certain regions that shows reduced blood supply, they are also the region that's known to be in charge of working memory, naming of the object, etc.
So, Dr. Liu, using these images from an MR scanner, can you please show us what is the white matter, the gray matter, and some abnormalities?
Sure. This is a typical image of a human brain. The outside structure of the brain is called the gray matter. The inside structure is called the white matter. The white matter in this particular image is supposed to be dark in healthy tissue. However, in this particular individual, as you can see, there are a few bright spots. These are indications of abnormalities. When an individual has this kind of abnormalities, the memory function, their emotion function can be disturbed.
We also are wanting to know that some patients have short-term problems after a concussion. We've heard about people not needing to be able to go to sleep or to have a headache or something. Is that directly related to some of these structural abnormalities?
We believe so. We believe white matter is important for people's brain function and cognitive ability. If the brain's white matter has deficit, then certain neuroactivity will be compromised, and that will disrupt their ability to sleep, to memorize, to control their emotion, etc.
So what are some of the major unanswered questions that you would still like to explore from this study?
One important question is how to use MRI as a non-invasive measure of the brain function to predict future cognitive dysfunction. Because it is important to detect deficit earlier, so therefore intervention can be performed at the earlier time point before it's advanced to a later stage.
So in terms of these stationary and rotating magnetic fields, you mentioned earlier that the machine will give us an image straight from the scanner. But how important is it for a student interested in this to know the physics and the math behind what's going on? Do you have to actually calculate using normal math that these students might be interested in, or does the computer do all of that?
For getting an image, computer would do it. But in order to understand the principle, there are some standard equations that the student can learn to understand how MRI works and what are the signal strengths of each image.
We're here with Dr. Benut Thomas, who is a recent graduate from the UT Southwestern, University of Texas at Arlington Joint Biomedical Engineering Program. Welcome, Dr. Benut. Thank you.
Thanks for having me here.
So you got your recent degree in biomedical engineering, correct?
That is correct.
How did you get interested in biomedical engineering, and how did you get interested in doing imaging types of studies?
During my high school days, I was really interested in how biological systems would function and just trying to answer some real scientific questions from these systems and trying to find out how I could solve these problems. So that's how I got interested in biomedical engineering and further did my master's and then my PhD in biomedical engineering as well.
Okay, thank you. So you said you started getting interested in this in high school. Did you do any experiences in high school or college to get you prepared for a career in research?
Actually, I got exposed to MRI research during my bachelor's, and I did more of that, specifically brain research during my master's. And I was very curious in trying to perform functional MRI studies during my master's, and I pursued my dream further with doing my PhD in the same biomedical engineering with brain imaging research.
Great. Well, thank you.
Thank you.